Hello and welcome. In this video, we will learn about recursion. Okay, this topic is a bit tricky, and so I will take a simple example first and explain you the concept, and then I will take a slightly complicated example. All right. Recursion is when a function calls itself to solve a smaller part of a problem. Okay? It is like one of those Russian nesting dolls, each one being smaller than the other. Alright? The reason we use recursion is because sometimes a problem becomes easier to solve by breaking it down into smaller versions of itself. Okay? Now, let me take an example of a countdown timer. Okay? First, I will show you how to write the program using a for loop and a while loop, and then I will explain it using recursion. Okay? So here I will say def and countdown and then n. Alright? And I will say for I in range n 0 minus 1. Okay, print I, and then at the end let me say print blast off. Okay, all right. So this is a function for countdown timer which starts the countdown from the number that we sent. When it reaches 0, it says blast off. Okay, let me run this and show it to you. I will say 10, and when I run this, it says, or it starts from 10, goes till 1, and then says blast off. Okay, so a countdown timer. Now I will use a while loop and write the same program. Okay, I will say countdown and I will say n, and inside I will say while n greater than 0 print n, and then I will decrement n. Okay, n equal to n minus 1, and at the end I will say blast off. Alright, I will comment this out and I will run the function and I get the same result. Okay, so we have written a small program that counts down from the time that we sent. It goes till 1 and then says blast off. Okay, I will comment this one too. Alright, and I will delete this. Now I will use recursion and achieve the same result. Alright, so here I will define the function countdown and pass n to it, and inside this function I will print n, and then I will call the function once again and pass n minus 1 to it. Alright, so this is the recursion function. Okay, now here outside the function I will call the countdown function and pass 3 to it. Okay, now when I run the program I get this error, maximum recursion depth exceeded. Okay, now why did I get this? Let us try to analyze. When we call this function countdown, and when we send 3 to it, 3 will be sent here and will be stored in n. So the value of n is now 3. In the function, we have this print statement. So number 3 will be printed out first. Okay. Next, when this line gets executed, the countdown function will be called once again and n minus 1 will be passed to it. Okay. Next, when this line gets executed, the countdown function will be called once again. Okay. So here we have our countdown function, and inside this countdown function we have a countdown function once again. Okay. So this countdown function will be called and n minus 1, which is 3 minus 1, 2 will be passed. So the countdown function will be called and number 2 will be passed to it. So the new value of n is 2. Here 2 will be printed, and when this line gets executed, the countdown function will be called once again, and now 2 minus 1, 1 will be passed to it. Okay. So when the countdown function runs once again, 1 will be printed and the countdown function will be called once again and 1 minus 1 will be passed to it. So the countdown function will run once again with 0 as the value of n. 0 will be printed and the same thing will keep repeating again and again till we get an error here. This is because we have not written a base case, meaning we have not written when to stop this. Correct? In the for loop, we wrote 0, meaning till 1. Correct? When we write 0 here, 0 is excluded. So till 1, in the step of minus 1, the program would be executed. And here we said until n is greater than 0, do this. But here we have not mentioned when to stop the program. Right? And so it keeps on running until Python crashes. And that is why we got the error when we ran the program. Okay. So now let us tell the function when to stop this. Okay. We want to stop when we reach 0. Right? So here we will say if n is equal to 0, and inside if we will say blast off. Alright. So we have said if n is equal to 0, print blast off. Else what should be done? Else we need to print n and we need to do the countdown. Correct? So here I will say else and I will indent this inside else. Okay. So now when I run the program, I get 3, 2, 1 and blast off. Alright. Now let us try to analyze this. When we call this function countdown and pass 3, 3 will be sent here and will be stored in n. First, it will check if n is equal to 0. Here, 3 is not equal to 0 and so this will not be executed. And since this is false, whatever is inside else will be executed. Inside else, we have this print statement. So first, n will be printed out. N is 3 and so 3 will be printed out. Next, countdown function will be called and n minus 1, which is 2, will be sent. So now n is 2. Once again, it checks if n is equal to 0. 2 is not equal to 0, and so this will be skipped and this will be executed. So here 2 will be printed out. 2 will be printed out. Countdown function will be called once again and 2 minus 1, which is 1, will be passed. So now n is 1. When this function runs once again, it checks if n is equal to 0. 1 is not equal to 0, and so this will be skipped and this will be executed. So here, when this line gets executed, 1 will be printed out, and when this line gets executed, countdown function will be called and 1 minus 1, which is 0, will be passed. Now n is 0. Here it checks if n is equal to 0. N now is 0 and 0 is equal to 0. So this comes out as true, and so blast off will be printed out and this will be skipped. So since we have this statement, we have this output and the program stops here. Alright, so this is how recursion works. Okay, we are calling the function inside the same function. Alright, and this here is our base case, which is super important because this is the stopping point of the program. Without this, the function would just keep calling itself forever until Python crashes. Alright, so what we are saying is when n equal to 0, stop counting down. Okay, no more recursive calls. Alright, yes. So the same result that we had obtained using for loop and while loop can be obtained using recursion too. Okay, but then we cannot use recursion for all the problems. Alright, when we compare iterative methods with recursion, iterative methods are faster than recursion. Alright, yes. So I hope you have understood. Now, let me take an example of calculating factorial of a number using recursion. Now first, let us learn what factorial is. You have learnt it in your school, but you may have forgotten it, so I will recall it quickly. Okay? 0 factorial is 1 and 1 factorial is also 1. Alright, so these two are simple. 2 factorial is 2 into 1. Okay, now what is 1? 1 is 1 factorial, correct? So 2 factorial is 2 into 1 factorial, correct? 2 into 1 factorial, which is 1. So instead of saying 2 into 1, we can say 2 into 1 factorial. 3 factorial is 3 into 2 into 1. Now what is 2 into 1? 2 into 1 is 2 factorial, right? So we can say that 3 factorial is 3 into 2 factorial. 3 into 2 factorial, which is 2 into 1, right? 4 factorial is 4 into 3 into 2 into 1. What is 3 into 2 into 1? 3 into 2 into 1 is 3 factorial. So we can say 4 factorial is equal to 4 into 3 factorial. In the same way, 5 factorial is 5 into 4 4 factorial. And we can go on like this. So n factorial is equal to n into n minus 1 factorial. Right? If we say n is 5, then 5 factorial is equal to 5n into 5 minus 1, 4 factorial. Right? So we can calculate factorial of a number using recursion. And let us do that now. I will say factorial and n. And inside I will say return n into factorial n minus 1. Okay, so basically I have this formula. Okay, n into n minus 1 written down here, n into n minus 1 factorial written down. Alright, now let me call this inside a print statement and pass 5. Okay, I will run this and I get maximum recursion depth exceeded. This is because by default there is a limit for calling the function again and again, and that is around 1000 times. Okay, so here we are getting this error because we have not mentioned our base case. What is base case? It is the condition which when reached the program must stop. Okay, that is not there here. So this would keep on calling the factorial again and again. Okay, so let us write the base case now. I will use these two as the base cases. Okay, I will say if n is equal to 0 or n is equal to 1, then return 1, else we will do this. Okay, now let me run this and it gives me 120. Okay, so this is running fine. Now what is happening here? Let me explain in detail. When we call the function by passing 5, 5 will be sent and stored in n. First time it checks if 5 is equal to 0 or 5 is equal to 1. This and this both come out as false, and so this will be skipped and whatever is inside else will be executed. Inside else we have return 5 into factorial 5 minus 1 or n minus 1, okay, which is now 5 minus 1. We are not returning anything right now. What we want to return is 5 into factorial of 5 minus 1. So we are calling the function once again and passing 4. Now 4 is passed to the factorial function. It checks if 4 is equal to 0 or 4 is equal to 1. Both come out as false, and so this will be skipped. And so whatever is in else will be executed. In else we have written 4 into factorial of 4 minus 1. Now once again factorial 4 minus 1, which is 3, will be called. Now the value of n is 3. It checks if 3 is equal to 0 or 3 is equal to 1. Both are false, and so whatever is in else will be executed. In else we have written 3 into factorial of 3 minus 1. So now once again factorial 2 will be called. Factorial 2. Here once again this becomes false and this will be executed. In else we have written 2 into factorial 2 minus 1, which is 1. So factorial 1 will be called now. Now n equal to 1. It checks if 1 is equal to 0 or 1 is equal to 1. Now it is true. This is true. And for OR, the entire thing becomes true if one of the expression becomes true. Since this is true, 1 will be returned and this will be skipped. So this value 1 will be returned to this. Okay? Why? Because this 1 is the result of this function call. So 1 will be returned here. Now it is return 2 into 1. Okay, 1 is the result of this. 2 into 1 is 2 and the value 2 will be returned to factorial 3 minus 1. Why? Because this return is the result of this function call. Okay, so factorial 3 minus 1 is now 2. 3 into 2 will be done and the value will be returned to factorial 4 minus 1. 3 into 2 is 6 and 6 will be returned here because it is the result of this function call. 6 into 4 will be done and the value will be sent to this, okay, which is 24, because 24 is the result of this function call. 24 into 5 will be done, which is 120, and 120 will be returned now and it will be displayed on the screen. Okay, so this is what happens when we run the function or when we call the function. All right, the function inside the function keeps getting called until it reaches our base case. This is why the base case is important. Okay, this is our ending point. When the base case is satisfied, the recursion stops. All right, and this is how we have 120 here. All right, this is how recursion works. Okay, if it is still confusing, please watch the video once again and it will make sense. All right.